Welcome back. This is structural analysis and design made fun and easy. So this is the retaining wall example 1. This is part 4 video. So in the last videos we looked at the lateral earth pressures active, and we found the pressures, the forces, and the moments. So now, remember we were trying to find the bearing pressures under the base, so it will be like a triangulated distribution. So now we're taking moment. It was that we would take a moment about the heel of the wall. So now we need to find the total vertical forces on the wall. The weights of the wall and the weight of the soil. So the height of the soil and the stem is the height of the soil is 5.4. So the height of the stem is 5.4 minus 0.4, because the base was 0.4. He's ignoring the chamfered. The width of the soil is 1.75, that's given, and QS is 40. So the unit weight of concrete is given as 23.5. So what we're going to find out is the weight of the stem, the wall, the weight of the base of the wall, the weight of the soil, and the force from the downward force on the base from the surcharge. It's very simple. The unit weight of concrete is 23.5 kilonewtons per meter cubed. But to be honest, it would just be easier if you said 24. So 1 is the weight of the stem. That is T, thickness, times height, times density of concrete, equals 0.3 times 5 times 23.5 equals 35.3 kilonewtons per meter length. 2 on the diagram, weight of base equals W times T times delta C equals 3 times 0.4 times 23.5 times equals 28.2. The chamfers are ignored. So he hasn't included those little chamfers in there. They're 45 degrees. I'm not sure. So 3 is weight of the soil. That is the block soil behind the wall. WS equals HS. The soil weight is the width of the soil, which is 1.75 times the height of the soil, 5, the same as the stem height, times 17 equals 148.8. And the load, the vertical force on the base from the surcharge is equal to 1.75 times 40 equals 70. So the total RV downwards is 35.3 plus 28.2 plus 148.8 plus 70. So that gives you 3, 2, 5, 8, 3, 13, so it's 282.3 kilonewtons. So the next part of the solution is to find all the moments about X. So we done the lateral soil pressures in the previous videos. Now we've got all the RVs. This is just what I do in the next video is you do RV. Obviously M equals RV times the eccentricity, so we're looking for pressures, maximum pressure under the base and the minimum, but this was just a summary of everything, all the moments. This is just a summary here I've done of the moments, just to show how everything's because he does the next step is to find the total moments about X. So it's F soil times the lever arm plus F surcharge times the lever arm, then weight of the stem times the lever arm, all from point X, which is here, times the weight of the base times the lever arm, times the weight of the soil centre of gravity, times the weight of the surcharge centre of gravity. So calculating the total moments about X. Total moment is F force of soil, and the lever arm is, that should be I think it was 1.8, wasn't it? Yeah, it was 1.8, about there. Then the force of the surcharge times, oh yeah, times 5.4 over 2, 27, 2.7. Oh yeah, so I've said, sorry, yep, and weight of the soil, and is weight of the soil, the weight of the soil, and times Z1, that is. So what I've done is I've just called all the lever arms, I've just labelled them as, on this diagram, Z1 is the lever arm for the surcharge and the soil, force W's, forces, Z2 is the lever arm for the base, Z3 is the lever arm for the stem, Z4 is the lever arm for the soil, Z5 is the lever arm for the surcharge. So the total moments is F soil times Z4 plus F surcharge times Z5 plus weight of soil times Z1, weight of surcharge times Z1, weight of stem times Z3 plus weight of base times Z2, and I can say that Z4 equals 5.4 over 3, which was 1.8, Z5 is H over 2, which is 2.7, isn't it? Yep. Z1 is 1.75 over 2. Z2 is 3 divided by 2, should be 1.5, and Z3 is 1.75 plus 300 over 2. So in the next video, in the next video, I'll then be able to work out the complete moments about X. Thanks for watching. Please like the video and subscribe to the channel. Thanks for watching. Look out for the next video where I'm going to work out what the moment is, and then I can find out what the pressures are.